Alright, the G84 can cycle is used for right-hand tapping. Okay, and the way the can cycle works is the tap rapids to an R clearance, which is normally about 100 thousandths. It turns the spindle on and synchronizes the feed and the spindle RPM that's programmed for that can cycle. Goes to the programmed depth, and at that depth reverses the spindle and feeds it out, making sure that the spindle speed and the feed rate again are synchronized so we don't break the tap. Okay, this is also considered a rigid tapping cycle, which means you can stick the tap right inside of a collet instead of a tapping head, and the machine is making sure that the synchronization between the start, stop and reversing of the tap is done smoothly, and most newer machines are very capable of rigid tapping. Now, some older machines have a little issue with the G84 can cycle. It can't quite synchronize that feed and speed, and so then a tapping head is definitely recommended to take up any slack there is between those two. Alright, so let's watch the simulation. We're not going to see a whole lot in the simulation, especially not the reversing of the spindle at the bottom of the hole, but you can see all these can cycles basically operate the same way, just the parameters change. So we're going to talk about how to calculate the feed rate based on the pitch of the thread. So let's take a look at that and then continue writing our program, and then we're going to complete this lesson. Alright, so we're back at our program, and at the top of the program we're going to add the tap. So we're going to make that tool number 7 and call that a 3/8/16 tap. Okay, so by the way, everything in brackets like that or parentheses is considered a man-readable. The machine ignores everything that's inside those parentheses. So you can put messages or anything that you want to communicate to the operator, and the machine will basically skip right over it. Alright, so we took care of the top of the program, and then again we're going to copy and paste. So I'm going to copy this whole operation again, enter, and then Control V. Okay, so now we have 2 peck drilling operations, and we're going to make some edits and turn that into a tapping. So I'm just going to call that a tapping cycle. Again, we're going to make a tool change from 6 to 7, and right away we want to look at the H value and turn that into a 7 also. So again, we wrap it to the first hole location, and let's talk about the RPM. And for steel, we're going to go ahead with a 200 RPM. And I know that is not really fast, but that is something very manageable and something that the machine can keep up with, especially on a small order. If you have a production run, you may want to consider running a faster RPM. But I would definitely make sure that you have the right tap, and you may have to do some research to see what exact tap with what exact coating, and then you want to know the specs for that particular material. But a 200 RPM is a good RPM for something right off the shelf, for a tap that's uncoated and just a standard tap all around. Okay, now let's move on to the can cycle. So we're going to change the G83 to a G84. We're going to go a little bit deeper because the tap will have a lead on the tip, and we want to make sure that we allow that lead to come all the way through the part. And you may just have to see how long that lead is and adjust that depth. Okay, so we're going to get rid of the Q value because we're not pecking, but then we need to talk about the feed rate. So in this case, we're using a 3/8/16 tap. So we're going to bring up the calculator again. We're going to clear everything. And so what does it mean when we have a 3/8/16 tap? Well, the 16 means that there are 16 threads per inch. So if we take 1 inch and divide that by 16, that means the pitch of the threads are 0.062 and a half, or a 16th apart. Okay, that is what the machine needs to know, is the distance between the threads. And then what we're going to do is, because our machine is set to inches per minute, we're going to multiply that times the RPM. Yeah, so in this case we picked 200 RPM. So that is 12.5 feed rate. So we're going to change this to a 12.5 feed rate. And that will synchronize the spindle using the 200 spindle speed and the feed rate and produce the thread without breaking that tap. Alright, so then there is no operation following this tapping cycle. So what we're going to do is we're going to squeeze a G88 Y0 in between here. We'll get rid of the M1. And then get rid of everything below it. Right there. Alright, so that's what the end of the program needs to look like. We wrap it home in Z, we wrap it home in Y, we change it back to G90 mode, and then of course the M30. So now we rewind the program all the way back to the top. Make sure that that cursor is at the top. Drag this down, turn on perspective. And then we're sitting at a simulation speed of 14. That's good. So let's play it and let's see what it does. So there's our facing operation. When you hold your right mouse button down and kind of rotate, you can kind of look at it from a 3D perspective. You change your view. And that looked good. So what I'm going to do is I'm going to attach a drawing in the email, and I want you to rewrite this program. It's going to be just a little bit different size. It's going to have holes in a different location, and we're going to use 1/4-20 threaded holes. So you will have to change the center drill, and tap. I want you to do that exercise. Find the correct center drill, the correct minor diameter drill, and then calculate your feet and speeds for that drill based on mild steel. And then also calculate your tapping cycle based on 200 RPM again. But you're going to have to calculate the feed rate based on that different pitch. Alright, so we're looking for that drawing as an attachment in the email. And then when you write the program, you don't have to start from scratch. What you can do is you just change whatever needs to be changed in this program. Okay, you change the descriptions of the center drill, the drill, and the tap. Okay, and then of course it probably would be a different part number, so that we would change. And of course you're going to determine where you're going to put the XY origin. So if you pick a different location on the part, then make sure that you write that in the top of the program. So usually you can leave the header and the footer portion of each operation intact and just change out the X and Y coordinates. Okay, so this is a good template. I would recommend that you build yourself a library of templates that you can easily access and just make some minor edits and use it for different parts. Now once you have written and proven the program and make sure that you made a good part, then always make sure that you hit the save button and save it in a folder with the correct name so that you can find it again next time you need it.